Let's see how you did with numbers parts B and C of number 9. So in part B, if you plug a foot length of 29 into the predicted height equation, you should get 68.17. So a person whose foot is 29 centimeters long is predicted to be 68.17 inches tall. And then in part C, they asked by how much those two predictions differed. So if we take the difference, aka subtract them, we get 1.03, which is actually the slope of the equation. So although you might not have realized it ahead of time, hopefully hindsight is 20/20. What we just did is compare predicted heights for people whose foot length differed by 1 centimeter. And in general, as the key idea box says, the slope coefficient in your least squares regression model is the predicted change in the response variable when the explanatory variable increases by 1 unit. And I'm going to just mention that the change here is considered to be an increase. Okay, so part D asks us to interpret the slope in context, and they actually gave us the sentence that we need, and we just have to fill in the blanks. So the slope of the regression line predicting height based on foot length is 1.03. This is the kind of sentence you yourself could write on a quiz or a test, meaning that for every additional 1 centimeter increase in foot length, the predicted height increases by 1.03 inches. Okay, so in this middle blank, that's always a 1. Every additional 1 unit, whatever that is for your explanatory variable, 1 unit increase in explanatory, and then the last blank there is always filled in with the slope value. So the slope tells you by how much the predicted value of the response should change when the explanatory variable increases by 1. Now, the word change in the response in the key idea box, that's not necessarily increase. That would be, actually, let's go ahead and write it down. That would be an increase if the slope is positive, and that would be a decrease if the slope is negative. So if the slope is negative, then that's saying each time the explanatory variable goes up by 1, we expect the response to go down by the amount of the slope. All right, and then number 10, let's investigate the meaning of the y-intercept in the context of height and foot length. Use the least squares regression line to predict the height of someone who has a foot length of 0 centimeters. So again, if we use our predicted height equation, and it doesn't mean predicted until we put the hat on. So 38.30 plus 1.03 times foot length. I'm going to be very good about writing everything out, and you should be too. So for a person whose foot length is 0 centimeters, and we'll talk about what that means in a minute, I'm going to plug 0 in for foot length, which means I'm taking 38.3 plus 0, because 1.03 times 0 is 0, and I get 38.3. So the predicted height of someone whose foot length is 0 centimeters, and this is how you would interpret your result. That height is predicted to be 38.3 inches. Well, what does that mean? Okay, so first of all, part B, your answer to A should look familiar. What value is that? The vertical or y-intercept. So anytime we let the explanatory variable value be 0 and we calculate the predicted response when the explanatory variable has a value of 0, we will always get the vertical intercept back. So the key idea here, the y-intercept of a regression line is interpreted as the predicted value of the response variable when the explanatory variable has a value of 0, but it says, though be wary of extrapolation, see the next key idea box. So what we did just now when we answered number 10 is extrapolation, predicting values for the response variable for values of the explanatory variable that are outside the range of the original data is known as extrapolation and can give very misleading predictions. Okay, so what does that mean? First of all, I'm going to write a on this. A foot length of 0 centimeters doesn't make any sense at all. Okay, so in this scenario, first of all, about the scene of a crime, presumably the person is at least, maybe at a minimum a teenager, but probably an adult. Right, we're not talking about a baby leaving a footprint at the scene of a crime. Second of all, even a baby when it's born has some positive foot length, not a foot length of 0. So to even calculate that doesn't really make any sense. They just wanted you to recognize the vertical intercept. Okay, but part C says, explain how your prediction of the height of someone whose foot length is 0 centimeters is an example of extrapolation. Okay, so here's what we're saying. In the data set, the foot lengths ranged, the smallest foot length there was 56 centimeters. Whoops, hang on. To 35. Sorry. The smallest foot length there was 22, and the highest was 35. And you can go back to the data set to check that. Okay, so in the data that we had, our foot lengths went anywhere from 22 centimeters to 35 centimeters. So a foot length of 0 is outside the range of the original data, and that's what makes it extrapolation. So in other words, not every original that's not the same as making a general prediction. So in other words, maybe nobody in the data set had a foot length of, say, 25.7 centimeters. I mean, I don't actually know. I'd have to go back and look. But maybe nobody in the data set had exactly that foot length. So we could plug that foot length into our equation and come up with a predicted height, and we could feel pretty good about how close that prediction is going to be. Whereas a foot length of 0 is just not even within the data that we had for foot length, and so that's considered extrapolation. Now, that's all we're going to do on this exploration. We are not going to do question 11 or 12 or 13 or 14 or 15. Of course, you are more than welcome to do these questions if you'd like, but you are not responsible for the information that is in them. Make sure you try the practice exercises for this section to know what is expected of you.